Look up at the night sky and there it hangs, our celestial companion, quietly orbiting Earth for billions of years, the Moon, humanity's first stepping stone into the cosmos. But something extraordinary is happening right now. Nations and private enterprises worldwide are turning their telescopes, their budgets, and their ambitions back toward that pale gray world. Not for flags and footprints this time, but for something far more valuable. What could possibly justify the enormous expense of returning to the Moon? Why are governments investing billions while corporations sharpen their business plans for lunar operations? The answer lies buried in the lunar soil itself. And what scientists have discovered there might reshape our entire future, both on Earth and beyond. In this video, we'll journey across the lunar surface to uncover the hidden treasures that have sparked this modern gold rush, from exotic elements that could power our cities cleanly for centuries, to rare minerals that modern technology desperately needs, to resources that could make lunar colonies self-sustaining. But there's a twist to this story. The race for lunar resources isn't just about profit or scientific advancement. It's about geopolitical power, about who controls the future of space exploration, and whether humanity can work together or will compete ruthlessly for the treasures of another world. I've always found it fascinating how the Moon, that familiar sight we've gazed upon for millennia, still holds secrets that could revolutionize our species. So let's explore what's actually up there and why it matters so much. Our journey begins with an element that sounds like science fiction: helium-3. Here on Earth, this isotope is incredibly scarce. To put it in perspective, if you processed 1 billion cubic meters of natural gas, you'd extract only about 15 kilograms of helium-3. Imagine draining an entire natural gas field to fill just a backpack. That's how rare we're talking. But here's where it gets interesting. Helium-3 represents the holy grail of clean energy. Unlike current nuclear fission reactors that produce dangerous radioactive waste, theoretical helium-3 fusion reactors would generate power without harmful byproducts or radiation risks. Clean, abundant energy that could transform civilization. So why don't we use it? Simple, we barely have any. Fascinatingly, our planet's magnetic shield that protects us from solar radiation has actually prevented us from collecting helium-3 for over 4 billion years. The sun has been broadcasting this element throughout the solar system via solar wind. Earth's magnetic bubble deflects it harmlessly away. The Moon, however, has no such protection. Explanation with wonder. Every square meter of lunar regolith, that's the dusty layer covering the surface, has been steadily absorbing helium-3 particles for eons. The concentration isn't enormous, perhaps 50 parts per billion at most, but it's distributed across the entire lunar surface, not trapped in rare pockets like on Earth, but everywhere, waiting to be scooped up alongside any other mining operation. Interestingly, China has explicitly stated that helium-3 extraction is a primary objective of their lunar exploration program. American, European, and Indian space agencies have all acknowledged its potential value. Russia is currently conducting feasibility studies. Even private companies are calculating the economics. The race is already underway, but helium-3 is just the beginning of the story. Now, because helium-3 concentrations are relatively modest even on the Moon, any mining operation would need to process massive quantities of regolith, which raises an obvious question: what else is in all that lunar dust? As it turns out, the answer is quite a lot. Let's explore what scientists have identified. The lunar surface is remarkably rich in fundamental metals: iron, titanium, aluminum, silicon, calcium, and magnesium. These aren't exotic or rare on Earth. We use them constantly for everything from construction to electronics. Many of these metals exist, locked within mineral compounds, and oxides that are difficult to separate. However, and this is crucial, the very process of extracting these metals produces incredibly valuable byproducts. Breaking down lunar minerals releases oxygen and hydrogen. Combine those two elements and you get water. Oxygen alone provides breathable atmosphere. Hydrogen can be converted into rocket fuel. Imagine establishing a lunar base that doesn't need constant supply ships from Earth, hauling every liter of water and breath of air across the 74 kilometers of space. That's roughly the distance of 30 Earth circumferences. Instead, the base could be self-sustaining, producing its own life support from the ground beneath it. Remarkably, unprocessed lunar regolith itself has practical applications. Researchers have successfully created lunarcrete, concrete-like building material made directly from moon dust. Glass can easily be manufactured from the same material. Scientists have even coaxed plants to grow in lunar soil, though hydroponics would certainly work better for feeding a colony. But perhaps the most valuable resources hidden in the lunar surface are the ones driving our modern technological civilization. Let's talk about rare earth elements. Paradoxically, these elements aren't actually rare on Earth. What makes them rare is how dispersed they are throughout our planet's crust. Rather than concentrating in convenient deposits, they're scattered thinly everywhere, making extraction enormously difficult and environmentally devastating. Think about your smartphone, your laptop, electric vehicles, wind turbines, advanced batteries. All of them depend heavily on rare earth elements. As the world shifts toward renewable energy and electric transportation, demand for these materials is skyrocketing. Here's where geopolitics enters the picture. Currently, China controls approximately 95% of the global rare earth supply chain. Not because they possess 95% of Earth's deposits, they control about 30%, but because they're willing to accept the massive environmental damage that mining them causes. Few other nations want to pollute their own territories with the toxic byproducts. The environmental toll is staggering. Extracting just 1 ton of rare earth elements can produce up to 2,000 tons of toxic waste, contaminated water, radioactive residue, scarred landscapes. The price is enormous. So here's the question facing humanity. As demand increases exponentially, do countries like the United States, Canada, Australia, and South Africa start tearing up their own backyards? Do we pollute Earth further while ironically trying to go green with electric vehicles? Or do we mine the moon instead? Fascinatingly, rare earth elements aren't more abundant on the moon than on Earth, but several deposits have already been identified. And here's the critical difference: pollution on the moon carries zero environmental or human health consequences. No ecosystems to destroy, no water tables to contaminate, no communities to poison. As demand inevitably rises throughout the coming decades, lunar mining could become not just economically viable, but strategically essential. Whichever nation or corporation controls lunar rare earth supplies will wield tremendous geopolitical leverage. Will China maintain its dominance by expanding to the moon first? Or will other spacefaring nations and private enterprises stake their claims? Which brings us to a fascinating legal question. Who actually owns the moon? Who has the right to mine it? The primary international agreement, the Outer Space Treaty signed by most nations in 1967, prohibits weapons of mass destruction in space, forbids military installations on celestial bodies, and prevents any country from claiming sovereignty over the moon or planets. But here's the interesting part. It says absolutely nothing definitive about mining, rights, or commercial exploitation. Additional treaties have been proposed specifically addressing space mining. However, interestingly, only nations without active space programs have signed them. The countries actually capable of reaching the moon. They've conveniently avoided making such commitments. Right now, it appears to be first come, first served. A cosmic land rush with trillion-dollar stakes and no sheriff in sight. So there we have it, our journey across the lunar surface, from exotic fusion fuel to common metals, to rare strategic materials that could reshape global power dynamics. From helium-3 that could power clean reactors for millennia, to minerals that could make lunar colonies self-sufficient, to rare earth elements that modern civilization desperately needs, the moon has transformed from a destination for explorers into a treasure house that nations and corporations are racing to unlock. The moon that inspired poets and guided sailors for thousands of years now represents something else entirely. Humanity's first extraterrestrial economy, whether we approach it through cooperation or competition, with environmental wisdom or reckless exploitation, remains to be seen. What do you think? Is lunar mining our inevitable future, or an expensive fantasy that will never pencil out economically? Will it unite humanity in collaborative exploration, or divide us with competing territorial claims? I'd love to hear your perspectives in the comments below. And if this exploration fascinated you, consider subscribing for more journeys through our cosmic neighborhood. Thanks for watching. All the best and see you next time.